Hello, today we'll be talking about motion graphs, and this is a graphical representation of the motion of various objects. So this is under the topic speed, velocity, and acceleration, and we draw graphs to represent the motion of various objects. So by the end of this lesson, you'll be able to identify a distance time graph, identify a velocity time graph, then you plot each of those graphs. Then you'll be able to solve questions on each of those graphs. Let's start with a distance time graph. A distance time graph is a plot of distance against time. So you have a graph that looks like this. This axis here, you have your time in seconds, and that's the horizontal axis. Then on the vertical axis, you have your distance in meters. So you could have something that looks like this, then you have it being straight this way. So if you look at this graph now, you can see that from 0 to, let's call this T1, from 0 to T1, the distance is increasing. Then from T1 upwards, up to the point T2, you can see the distance is not increasing. The distance is fixed. As time increases, but the distance is fixed at this level. If you call this 5 meters, I will call this one 10 meters. That means the distance is fixed at 10 meters. Distance is not increasing with time. And from 0 to T1, distance is increasing. But from T1 to T2, distance is not increasing. So that is what a distance time graph does. It gives you a visual representation of the motion of an object. While for a displacement time graph, you just replace this distance with displacement, and that's all. Every other thing is the same thing. So if you look at the graph here, so this is a distance time graph. You can see the distance occupying the vertical axis, and the SI unit is here. The distance here is kilometers, and the time here is given in meters. So if you were to calculate the speed of this graph, for instance, your SI unit will be in kilometers per hour. Let's assume you were asked to calculate the speed of the object that is represented by this graph. Calculate the speed of the object from time 0 seconds to 10 seconds. So we are picking 10 seconds. So what do? Your speed is equals to distance, change in distance divided by change in time. What's the distance? We pick the distance covered within that 10 hours, 10 hours. So let's assume we are picking 10 hours. You have to calculate the speed of this object within the first 10 hours of its journey. So we pick the distance. What's the distance covered? After 10 hours, so it traces from 10 hours to this slope. They trace it to the distance covered. So that means after 10 hours, this object has covered a distance of 10 kilometers. So the distance traveled is 10 kilometers divided by, we said after 10 hours. So that 10 hours represents our time. So our time is 10 hours. So if we divide distance by time, the answer will be 1 kilometer per hour. This is the speed of the object from 0 seconds to 10 seconds. Let us assume you were asked to calculate the speed of the object from 10 seconds to 12 seconds. What do? You use the same formula, distance divided by time. What's distance covered from 10 seconds to 12 seconds? Start from 10 seconds up to 12 seconds. Actually, most textbooks represents the formula for speed as change in distance divided by change in time. So is there any change in distance from 10 hours to 12 hours? There's no change in distance because as 10 hours, the distance covered was 10 kilometers. And now at 12 hours, takes 12 hours to the slope. At 12 hours, the distance covered is still 10 kilometers. So if you want to calculate the speed, 10 minus 10 divided by 12 minus 10. Why did I say 10 minus 10? Because at 12 hours, the distance covered is 10 kilometers. That's how I got this 10. At 10 hours, the distance covered is still 10 kilometers. That's how I got the second 10. Divided by the change in time, 12 minus 10. You get 0/2, which is 0 kilometer per hour. And that is true, judging from this place. This represents stationary. That means the object is not moving. While here, we have a velocity here. That means the object is moving, hence it has a velocity. So at this place, the object is in motion. Also in this place, when you see the slope moving up, then you also know that at this place, the object is in motion. If you were to calculate the speed of the object from 12 seconds till 16 seconds, you use the same formula. You say speed is change in distance divided by change in time. So let's calculate the speed from 12 seconds to 16 seconds now. So change in distance at 16 seconds, hours rather. Time is measured in hours here. So at 16 hours, the distance covered was 14 kilometers. So we have 14 . Yes, so the time is from 12 hours to 14 hours. From 12 hours to 16 hours, that's the time. From 12 hours to 16 hours. Let's pick the distance at 16 hours. At 16 hours, our distance was 14 kilometers. So we have 14 minus, at 12 hours, our distance was 10 kilometers. 14 minus 10 divided by, I said the time will be from 12 hours to 16 hours. So we use that 16 and 12 as our time. 16 minus 12. From this, you see that at 16 hours, we have covered the distance of what? We have covered the distance of 14 kilometers. Yeah, 14 kilometers. At 16 hours, we have covered the distance of 14 kilometers. And that's what we have here. At 16 hours, we cover a distance of 14 kilometers. Minus, at 12 hours, we must have covered the distance of 10 kilometers. So at 12 hours, we have covered a distance of what? 10 kilometers. So that's how you calculate the speed. So let's see, 14 minus 10, we have 4, divided by 16 minus 12, we have 4. So our speed is still 1 kilometer per hour. So at this place, from 0 seconds to 10 seconds, the object was moving at a constant speed of 1 kilometer per hour. After 10 hours, the object became stationary. It did not move. Probably a car. The car rested for 2 hours. Okay. Then on the 12th hour, the car started moving again at 1 kilometer per hour up to 16 hours. Probably the car must have come to a stop here. So this graph is a visual representation of the motion of an object. So it's not every time that the question will be written in a grammatical representation. You could be given a graph like this and asked to make your deduction from that. So that is what has been explained here. This represents traveling at constant speed. That's how you have a straight slope. If the speed was not constant, if the object was accelerating, take note that this slope would be curved upwards, indicating the object is accelerating. And if the object was decelerating, if the object initially was accelerating, then later began to decelerate, this curving upward represents the path that involve acceleration, and curving the other way represents the path that involve deceleration. Okay, this straight line represents uniform velocity. The straight line from here to here, you see, distance is not increasing with time. So if the slope begins to curve downwards, that represents deceleration. If the slope begins to curve downwards, that represents deceleration. And that is what I was trying to express here. So from here, this region here represents deceleration. That means the speed of the object is reducing. That's what we mean by deceleration. So all I've said, that is what this graph represents. This is the stationary point, and below here is traveling at constant speed. Okay, here is also traveling at constant speed, which I proved with the calculation I just did. So that's it. And if you're calculating the speed, you divide the distance by the time. And that's what they solve in the next slide. They divided the distance by the time. They got 1 kilometer per hour, which was what I got. Now look at this graph. Let's assume you were asked to calculate the acceleration within the first 2 seconds of his journey. Okay. Also, you were asked to calculate the deceleration within the last 4 seconds of his journey. How you calculate acceleration? This formula for acceleration. Acceleration is final velocity minus initial velocity divided by change in time. Yeah. So T2 minus T1. Normally, ideally, acceleration is given by the formula change in velocity divided by change in time. Okay, and that's the same thing I've written here, because the change in velocity means v minus u. That's final velocity minus initial velocity. And your change in time means the time at the end, which is T2, minus the time in the beginning, which is T1. Let's deal with this part of this graph. Take note that this is a velocity time graph. So the slope of this graph represents your acceleration. Take note that the first example we solved, our graph was a distance time graph. It was a distance time graph. So the slope of this graph can only represent your velocity. And here, your velocity here is 0 because it is not moving. It is at rest. The distance did not change, even though the time was changing. The time increased from 10 hours to 12 hours, but the distance did not change. So at this place again, it has some velocity. That's uniform velocity. It has uniform velocity. That's for the distance time graph. The slope, okay, the slope, this slant line of a distance time graph represents the velocity. Okay. While if you are dealing with a velocity time graph, you see the vertical axis is your velocity, this velocity, and this is time. So if you are dealing with a velocity time graph, the slope represents the acceleration. Now you have to calculate the acceleration of this object within the first 2 seconds. What will you do? You use the formula for acceleration. Acceleration is v minus u over t. V minus u over change in time. And that's what we've written here. V minus u divided by change in time. So the first 2 seconds, what's velocity at 2 seconds? Velocity is 3. 3 minus u. Velocity in the beginning was 0 seconds. Yes. 3 minus 0 divided by T2. Okay, here we use our T2 as 2 and our T1 is 0, which is the origin. So you have 2 minus 0. That will be 3 divided by 2, which is 1.5 meters per second. So that is the speed of meters per second square, because what I just calculated is acceleration. So I have to put the square here, yes. That represents the acceleration of the object within the first 2 minutes. So take note that within the first 2 seconds, take note that from 2 seconds to 5 seconds, the object traveled at uniform or constant velocity. What does that mean? It means the velocity did not increase despite the fact that the time was increasing. So the velocity is constantly at 3. Okay, from 2 seconds to 5 seconds, the velocity maintained that value of 3 meters per second. So this constant velocity. Take note that constant velocity does not mean an object is not moving. Okay, uniform velocity or constant velocity, anyone you call it. Your uniform velocity does not mean an object is not moving. It simply means the object is moving at a constant speed. And this is what this is a visual representation of uniform velocity. Okay. Yeah, so it means the object is moving at a constant speed. So that is what we have here. When you have a straight slope, then you know that you have uniform velocity. But when the slope is curved, this way, then you know your velocity is not uniform. It's clear, right? Good. Let's proceed to something else. Okay, so let's assume we are asked to find the deceleration of the particle. What's the deceleration? Deceleration is initial velocity minus final velocity divided by change in time. What's the initial velocity? That's the velocity in the beginning. Our initial velocity is 3 minus our final velocity at the end is 0. Velocity at the end rhymes with 0 because this slope has come down here to this point, and this is the velocity axis, 0. So this point here is reading 0 velocity. So we have 0 as our v, which is our final velocity in this case. You know, the object went from here, accelerated from here to here. So if you are dealing with this part of the motion, this is the initial velocity, this is the final velocity. If you are dealing with this part of the motion, this is the initial velocity, this is the final velocity. If you are dealing with this part, which is deceleration, this is the initial velocity, and this place, the end, is the final velocity. So our velocity here at the end is 0, which corresponds to 0 on the vertical axis, 0. What about our time? It will be time taken for this to happen. What's the initial time? 5. Okay, change in time, that's the span of time taken. What's the change in time? Okay, so that's our initial time minus final time. That's what we're supposed to do ideally. But our change in time must always be positive. So you cannot come and say initial time minus final time. No. Change in time must always be positive. So we do 8 minus 5 divided by 8 minus 5. 3 minus 0 gives us 3. 8 minus 5 gives us 3. So that means our deceleration is 1 meters per second squared. Now take note of one thing. When you say a particle is decelerating, that means the speed is reducing with time. Okay? And deceleration is negative acceleration. So when the speed of a body is decreasing with time, we say the body is decelerating. Now you can see that we calculated the deceleration from 5 seconds to 8 seconds to be 1 meter per second squared. If you decide to calculate the acceleration from 5 seconds to 8 seconds, you get minus negative of this value. Why? Because deceleration is negative of acceleration. That also means acceleration is negative deceleration. That is what it means. Acceleration occurs when speed is increasing with time, while deceleration occurs when speed is reducing with time. So this object decelerating at 1 meter per second squared, it means its speed reduces by 1 meter for every 1 squared second. So that is what this graph is explaining here. This steady acceleration, steady velocity, steady deceleration. If the acceleration was not steady, it will form the shape of a curve like this. Okay, so if the velocity is not steady, that wouldn't be obvious. The curve will still continue. And if deceleration is not steady, if deceleration is not uniform, it will form the shape of curves like this. So that is what we have when your acceleration or your deceleration are are not uniform or constant. Just ensure you understand the main point. The main point is how to calculate the acceleration, deceleration, speed from all this question. And that is what they have done here. Here they are solving it. Here they solve the acceleration here, and they also solve the deceleration. And that's okay. They didn't bother doing that. The question does not request for that. Let's deal with some questions here. Okay. So here you have to calculate the acceleration for each of the 4 sections of the graph. There are 4 sections in this graph. This is the first one, which is the accelerating. This is the constant velocity. This part of it is constant velocity. Then the particle accelerated again up to 30 seconds before completely decelerating from 30 to 50 seconds. So you have to calculate acceleration for each of them. What's the acceleration here? Acceleration here is final velocity minus initial velocity divided by the time taken, divided by the change in time. What's the final velocity? 40 minus what's the initial velocity? 0. What's the time taken? The time taken is 10 seconds. 40 minus 0, that's 40. 40 divided by 10, that will be 4 meters per second square. What about this part of the motion? When you see that velocity is constant, then you know automatically your acceleration is equal to 0. Okay, it is here that your acceleration is 4 meters per second square. Here your acceleration is 0. And if you want to solve it, you say acceleration is v minus u divided by change in time. What's final velocity? 40. What's the initial velocity? It's still 40. Divided by, what's the time taken? 20 minus 10 is 10. 40 minus 40 will give you 0. 0 divided by 10 is still 0 meter per second square. This is the top part. The time increased from 20 seconds to 30 seconds, and the velocity increased from 40 meter per second up to 60 meter per second. So what's the formula for acceleration? Acceleration is v minus u divided by change in time. What's the final velocity? V. V is 60. 60 minus, what's the initial velocity? U. U is 40. 60 minus 40. What's time taken? 30 minus 20 divided by 10. Yeah, because 30 minus 20 gives us 10. So I put 10 here. 60 minus 40 is 20. 20 divided by 10, that will be 2 meters per second square. Okay, let's do the third one. Take note that the question says you calculate acceleration. You are not to calculate deceleration, you have to calculate acceleration. Since the speed is reducing with time, then automatically you should know very well that your acceleration should be negative. Yes, because this particle is actually decelerating here, it's not accelerating. So if you calculate our acceleration here, our answer should give us a negative value. Okay, so acceleration is initial velocity minus, acceleration is always equal to final velocity minus initial velocity divided by time. Yes, acceleration is equal to final velocity v minus initial velocity u divided by time. Acceleration is equal to, what's our final velocity? Our final velocity is the velocity down here, which is 0. So you have 0 minus our initial velocity is the velocity in the beginning here, which is 60. Our change in time, is the time change from 30 seconds to 50 seconds. So our change in time will be 50 minus 30. So our acceleration is 0 minus 60, we have minus 60. 50 minus 30, we have 20. Minus 60 divided by 20, our acceleration is minus 3 meters per second square. Why did I get a negative answer? Because the body is actually decelerating. It is not accelerating. So deceleration is a negative of acceleration. So you always get a negative answer when you calculate deceleration. When you calculate acceleration, in a situation whereby you're supposed to be calculating deceleration. So that is it. All I've talked about so far is what they are still talking about on the graph. So I just want you guys to take notes that for the velocity time graph, the vertical axis is the velocity and horizontal axis is the what? Is the time. Yeah. So that's it. Is there any other question we need to solve? Okay, so in the absence of any question, this will be all for today. Thank you very much for listening. Do have a nice day. I will see you some other time. Goodbye.